Hi everyone, welcome to UChicago ICPC. Today we will walk through 2025 ICPC Asian Pacific Problem G, corrupted file. Given a file B, which is made up of 0 and 1 bits, you can combine two adjacent bits into one, and if both bits are 1, you will result in a 1, but if any of them is 0, such as 0 and 1, the output will be 0. Can you produce file C using arbitrary operations? In this example, you can produce file C by combining the first two bits into 1, and then combine the second two into a 0, and then combine the third and fourth into a 0, and then the last two into a 1. Or we don't combine the last one, just keep them as two ones. So this will produce 1, 0, 0, 1, 1, which is the desired file C. What is an initial thought? Dynamic programming, such as edit distance, which is for index I and index J. Can we combine the segments of B from 0 to I into 0 to J in file C? So dp of I and J will equal to, we can say if Cj is equal to Bi and Bi minus 1, which means by producing the AND of these two, we get a 1. And if any of them is 0, the AND of 1 and I minus 1 will be also 0. So if at the current index of I and J, if we can make them combine, we can just move on to the previous section to see from 0 to I minus 2, are we able to combine it into J minus 1? So if the last position is satisfiable, dpij will equal to dp minus 2 and j minus 1, right? Or if the last two digits are the same, cj is equal to bi, then can we perform 0 operations and directly use the I minus 1 result and the j minus 1 result? dpij is also equal to dp, so dpi minus 1 and j minus 1. What is the time complexity of this method? It should be O(n) squared, or O(n) times m, which is, let's say, C has a length of m and B has a length of n. So the time complexity is their multiplication. What if m and n are both 10 to the 5th? We can't use a two-dimensional dp, right? What is the correct approach? It is greedy algorithm. There is an important observation, which is we can divide B into segments of the same bits. So if this segment 1, segment 0, segment 1, segment 0, segment 1. And if this B has a segment of many ones, we can reduce it to any length, right? And if it's a O0 segment, we can also divide it into any length. But what if we have segments of 1 and segments of 0, and maybe some 1 here? If it's a mixture of segments, we can reduce this to a 0 segment. Why? We reduce this to 1, and then combine this with 0, which produces 0, and combine with the second. So we can reduce it to a segment of value 0. Okay, now let's write C also using this segment idea. Here is 1, 0, 0, 1, 1. Writing it into segments, we say that the value of segment 1 is 1 and denote it as C1. For its length, we use k. So the k is equal to 1. For segment 2, the value is 1, the length is 2. Segment 3, value is 1, length is 2. With this trick, how can we proceed? we loop it through from the first segment to the last segment. For each segment of C, take the minimum prefix of B that can satisfy this segment. For each segment, say CI segment, CI. So what does satisfy mean here? If the CI segment has a value of 1, we increase the index j in B until we find a segment of length at least ki. And if ci is 0, for this example, because segment 2 has 2 zeros, we will increase j until we find 2 zeros. So we will combine this entire segment. Make sense? Because this, and finally, for the last segment of C3, the value is 1. So we follow the first rule, increase j until we find a segment in B with length at least ki. Here, this segment in B has exactly 2, length 2, so it is satisfied. What is the time complexity? It's O plus n, right? Since we increase C and increase J all the time, so at most it's it's the length of C plus the length of B. We don't do any loops backward. Thank you for watching.